So we're going to go over a few different things today, a couple different definitions that we'll use with our triangles. We're going to start with a perpendicular bisector. As you see in this picture, line L is the perpendicular bisector of segment AB. So the video is going to pause, or you can pause on your own. Come up with a good definition. What's a perpendicular bisector? So let's say a perpendicular bisector is a line, and I'm going to put in parentheses a segment, because it could be a segment as well. Okay, so it's a line or a segment that's perpendicular to a segment and that it also passes through the midpoint. So I'll write passing through its midpoint. So perpendicular makes that 90-degree angle. Bisector cuts the segment in half, so it goes through the midpoint. There's our perpendicular bisector. In triangle ABC, segment CD is drawn. It's an altitude. You know the game. What's an altitude? All right, so we said before an altitude is a segment. And we'll say it's a segment from a vertex that is perpendicular. We see that right angle in there. Perpendicular to the opposite side. And let's talk about that idea of the opposite side. If we're standing up here at angle C, the opposite side is side AB. Now, if we start at angle A, though, we can draw another altitude. And if we start at B, we could draw another altitude. So triangles have 3 different altitudes. And maybe you've even seen the obtuse triangle. Kind of looks like this a little bit. And have you seen that it has an altitude that's outside the triangle? Maybe you've seen that picture before. So at least now we know what an altitude is. Our third one for today is a median. What's a median? Well, judging by my picture, it looks like it's another segment. And it starts at a vertex. So it's a segment that goes from a vertex. And this time, take a look at where point M is. Point M, by these 2 markings, is the midpoint of side BC. So we're going to say a median is a segment from a vertex to the midpoint of the opposite side. That's how we're going to define a median. And like before, I can find the midpoint of side AC. Maybe that's like point P. We'll mark it as a median, or we'll mark it as a midpoint, and we'll draw a median. And I'll find another midpoint. Let's call it like point N. And I'll draw in another median. Let's make that a median. Now it's a median because that N is a midpoint. So triangles have 3 medians. Oh, and this is fascinating too. Those 3 medians intersect at the same point. And that point is called the, are you ready? Are you ready? Dun, da, 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 the centroid. So the centroid is the point that we refer to as the intersection of the medians. That's where the centroid lies. And we've seen this little symbol before in my classes. It brings up Geometer Sketchpad. So we're going to take a look at a little sketch here. I have triangle ABC, medians AF, BD, CE. They all intersect at G, the centroid. And I told you before that G is always that intersection. I can drag this triangle around a little bit. And as you can see, no matter where I drag it, point G stays as the intersection of the medians. It's the centroid. So we're going to watch a few things and see what happens. Here we go. I'm going to press median 1. Oh, well, look at that thing move. How cool is that? All right. So then segment AG. How many times larger than FG is AG?
Would Joe Henry please come to the main office? Joey Henry, please come to the main office.
Joey Henry's going to the main office, whoever Joey Henry is. So maybe you recognize, since that flipped over twice from A to G, and then it flipped over once from F to G, that how many times larger is it? It's 2 times larger. Let's keep going. Let's hit median 2 and see what happens. Okay, same idea. Same thing going on. So this question is, what fractional part of BD is BG? So notice that that thing flipped a total of 3 times, and 2 of them were on BG. So BG is 2/3 of BD. And let's do one more. Median number 3. Ah, this is so cool. So this time we want to know what fractional part of CE is EG.
Mr. Glenn, please pull 1300. Mr. Glenn, please pull 1300.
So now we want to know, what about the smaller part to the whole thing? Well, this time it's 1/3. So that's going to lead us to our conjecture for the day. The centroid conjecture. The centroid of a triangle divides each median into 2 parts, so that the distance from the centroid to the vertex is twice the distance from the centroid to the midpoint of the opposite side. That's really wordy. Let's take a look at it in a picture. Here's a triangle. Here's a median. Here's the centroid. What it means is that the distance from the centroid to the midpoint of the opposite side, if I call that distance x, the distance from the centroid to the vertex is twice as big. It's 2x. So let's practice one together. In this triangle, G is the centroid of triangle ABC. We have some measures. Let's pause the video and see if you can find those 4 missing measures. Go ahead, I'll wait. Great, welcome back. How'd you do? Let's talk it through. So the first one is that AD is 24. I know that the centroid divides it into a 2/3, 1/3 part. So AG is 2/3 of AD. So 2/3 of 24. Watch what I'm going to do here. That's the same as doing 2 times 24 over 3. Because I don't know what 2 divided by 3 is. And then multiplying that by 24, that's crazy. But I know 24 divided by 3 is 8. And multiplying it by 2 is 16. So I know that AG is 16. And likewise, DG is 1/3 of AD. So that's 1/3 of 24. 24 divided by 3 is 8. So that's how big DG is. So it looks like that length is 16. Let's do this. That length is 16, that length is 8. And let's keep going. CG is 18. Well, we know that that distance from C to G is twice as big as from F to G. So 18 is twice as big as 9. So GF is 9. And our last one, if we know GE has a length of 7, BG is twice as big as that. So BG is 14. So that's some work with the centroid. That little relationship, that's a fun one. I like it.